Good morning to all of you. It's a privilege to be on this occasion to part the experience that I've gone through in the last 3 to 4 years finding an alternate fuel to our diesel-powered trucks. Okay, just to start the context, our company, as you know, is a second largest vehicle manufacturer in the CV segment, and it's a 4th in buses and 19th in truck manufacturer around the world. We have our own vision and purpose, and our values are innovation, agility, trust, customer centricity, and partnership. We are the part of the Hinduja group, as you are all aware. I will just go through my presentation quickly to cover the contents where I'll be trying to show you what's the impact on the global greenhouse emission. ICE is nice is the word we are coining. So ICE is internal combustion engine, and we say there's a lot more in this engine technology for us to power these trucks and mobility for the future. What is the decade of transition? There's a lot of things that is going to happen as we are also working on, all of you, on green manufacturing. But at the same time, we need a mobility solution which is also green in nature. So we should look at, as we are going around with the present IC engine, which was considered to be more polluting because of the carbon fuel that we're using, is there still more left in IC engine technology that it would be able to still power our vehicles and also be green? And we will also try to coin a word. Is it the time that we have to close the carbon age and look at some hydrogen age? So carbon is what we has powered all our vehicles. Should we look at hydrogen as an age? And we will just sum up with some of the hydrogen technology as a journey, and also in-house development with global partnership that we are working. So I'll go to the first topic, which just to set a context to all of us here. As you see that this data may be slightly older, but just to give a context, out of the 56.8 gigatons of CO2 that is emitted, you can see 14% is coming only from transporting sector. So which is a big concern, and we need to really look at this. And I think we are all seeing the global warming phenomena that we were all talking that it will take some years to come, but it's all happening as we are talking. The summers are increasing, and so many other calamities that are happening is just because of the CO2 emissions. Coming to specifically out of the transport, you can see road transport is covering about 73%, which is getting emitted. So it's a big concern that so much of vehicles are getting added into the everyday life, but what are we going to do that unless we control the CO2 emission from these vehicles? And also, as you see, there's a lot of focus from the government in terms of finding alternate fuels as a solution. And also, one of the biggest problem for our country is that we import more than 85% of our crude oil to power all of vehicles, as you know. And that's a lot of exchequer that is getting out of the country. And so what are the alternates to this? As you see at the bottom, you see there's a lot of alternate possible for us in terms of technology, from CNG, LNG, hydrogen, methanol, hybrid EV, battery electrical vehicle, and the fuel cell. I myself has worked for almost 3 decades on only one fuel, which was diesel, for almost 3 decades. And in last 3-4 years only that pressure has come on us that we need to find an alternate as a solution. So I happily worked on diesel as a technology, but now I'm seeing that there is a lot more available in the engine which we could have worked. But only thing is, I think under the pretext that infrastructure is not available, we are not looking at these fuels as an option. As we are talking, you can already see there are about 8,000 CNG gas stations across the country, which is slowly started moving our CNG vehicles, not even at the car level, but even for a smaller trucks, about in 12 to 16 segments, we are today almost selling about 500 vehicles per month. Actually, you had seen at some point of time that the CNG prices were lower than diesel. Actually, there's a lot more customers who actually moved to CNG as an alternate because the TCO was proving to be better. But then the prices of CNG also went up as other wars across the country went up. But if there is a good amount of parity between diesel and CNG, then, and also with number of gas stations that are coming, I'm very sure that CNG as a technology will pick even for the CV segment. The other thing which is also slowly picking, which you would have not seen, is an LNG as a vehicle. So LNG, the difference is it's the same methane gas like CNG. The only thing is it is stored at about minus 161 degrees C, which means to say that you can store more energy in a given volume. So in one cylinder, you could store in a 450 liter about 200 kgs. And if you could pack 2 cylinders, you would get about 1,200 to 1,300 kilometers of range in a truck segment between 28 ton to 38 ton segment. So the anxiety of the range will get out of with the CNG, but CNG has a number of stations has to pick up. But this is happening as we are speaking. So just to tell the market dynamics, I can see that the CO2 commitments are not only from the government, but as all the bigger organizations are looking at how to really have contribute towards the CO2 as towards CO2 by opting for alternate fuels by big OEMs like Amazon, Flipkart. These are all happening. Net zero cannot be achieved, as you see, without H2 mobility, I would say that. While EV is one part of the technology, but you know the game of if EV electricity is produced or powered from a coal, then it's only shifting from a city to elsewhere. But then the option is to go for green hydrogen, and if you can split the water using any renewable source, then that would be the ideal solution. But there are challenges for that. So large investments are happening, as you see that many investments have been announced by big companies like Reliance, and if these things are going to happen, then hydrogen as a technology has already started. In many of the seminars that I've attended, I already see there's a very good focus to go for green ammonia and also melt steel by hydrogen. PLI schemes are in place. DST has funded about 20,000 crores on the hydrogen projects, as you are all talking about. And many projects are now, we are talking about corridors. We will be running hydrogen trucks to prove whether this is a viable solution. These are all happening. And as you see, there is going to be more of other things. But the cost of hydrogen is higher today. It's about $10 per kg, which is undeniable. But the target there is to be between $1 to $2 per kg. And this is going to happen. The other thing is just again to set a context, you can see India is a growing economy at $4 trillion going 5 and 6 and 8. The energy consumption by every sector is going to increase day by day. So that means to say, if that is not going, it's going to get consumed by fossil fuel, then you have more and more CO2 emission getting into the thing. Similarly, this is the data up to 2045. You can see even in the transport sector, from about 2 million barrels per day, it could go even touching about to 5 million barrels per day, only for the country like India. This is the other thing which is signed by COP, as you know, where we are all working out how to look at what's happening around. You can see there is a lot of things which are happening, and you can see between now to 2030 to 2070, there's a lot of targets that we have got in terms of getting to net zero, even to reduce emission intensity by about 45% by 2030 and becoming net zero by 2070. So ice is nice is a coin that we are wording words. So as you see that in the smaller vehicle segment, it's much easier possibility to go with an EV, say for a two-wheeler to car, or a very small truck up to 2 ton. But beyond that, 3.5 and going bigger, then it becomes a catch-22 situation where battery-powered vehicles will be expensive, and also it will take a lot of space and weight in the vehicle, then you will have less and less weight to carry. So that's where we are looking at some kind of a carbon-neutral fuel or hydrogen based fuels, and you can see those are one of the viable solutions. And there is a lot of scope with even with IC engine, with electrical hybrids that are coming up as an option that is all being looked at. So can we reduce emission and still grow with IC engine is the point we are talking about. Just this is a kind of a fuel map. You can see IC engine can be work both on compression ignition and a spark ignition. And in each of these technology, we can work on mono fuel, dual fuel, and a flex fuel options, as you see. And now on IC engine based, as you know, it's mostly the battery electrical vehicle and the fuel cell, which has been talked about in Europe, where there will be no engine, but it's a fuel cell powered truck. So this is an array of fuel that is available for all of us to work. And why we didn't work on the fuel is a question that we have to ask ourselves. So there are mono fuels, there are dual fuels, there are flex fuels, and within the fuels we could operate between a spark ignited, compression ignition, or the no ignition. No ignition would be a EV or a fuel cell, I said. So what has happened was we were very comfortable working on tube fuels which are really carbon intensive, as I'm showing in your next slide. You can see diesel as a fuel is about 12 carbon atoms, which would have about 86 carbon by atomic weight, and simply you see the same fuel, if it is a gaseous fuel like CNG, it is CH4, so single carbon atom, lot of hydrogen in it, and the emission would reduce by about a significant amount, especially the particulate matter and the particulate number, just by switching over the fuel for the same performance and even a better fuel consumption. I would like to use the word, carbon is our enemy and not the internal combustion engine, is the point that we have to look. So any fuel which is less carbon intensive would be the way forward for us to go around. And just to tell you, in terms of diesel engine technology, the same diesel engine, if you migrate to a CNG, the complicated after treatment that you are seeing on the left with all that complicated, very costly system of after treatment to meet the BS6. With a simple three-way catalytic converter, you can see we can almost get down to the emission levels very close to the diesel levels, about 90%. So that's the technology which we are all pushing today to and be ready for the alternate fuel. This is just to say, if you have a diesel vehicle, just by adding these parts which I am showing from a oil separator, spark plug, and these parts are all well matured today in the market, that if you can plug these parts into your IC engine, you could already make your diesel powered vehicles equal to the CNG vehicles. And this is just to say, at a vehicle level, just by having this modified CNG engine, three-way catalytic converter, and a small muffler, the vehicle becomes a CNG vehicle. And also, just to set a context, you can see the India as a country. When I started my career in way back in 1996, you can see we started a BS1 in 2000, and today we are at BS6 in 2020. That means in 20 years, we simply moved the cycle from a BS1 to BS6, while Europe even took 22 years. And you are all aware that India was the only country which skipped the BS5 and directly went to BS6. So in that context, I think India as a country has done very well on this subject. And this is seen typically in terms of emission levels. You can see from where I started myself, NOx has been down by 95%, PM by 97%, hydrocarbon by 88%, and of CO by about 67%. So significant drop that has happened. And including with that, the engine noises have also been reduced by about 15 to 18 dBA, while the fuel economy has also improved. So these are all the challenges that we had. While we improved emission, we did work also on this. This is a very important slide just to give an idea. Till 2020, we worked very happily with one or two fuels, which was diesel and CNG, and very small vehicles we were trying to do an EV as a thing. So this is called a decade of transition, or more or less it is a decade of messy middle. That means to say, we as an OEM has to work on all alternate fuel in terms of development, make sure that the technology is available, while the infrastructure to supply these fuels in the market would be a challenge. It may take some time. And we expect by 2030, there will be some kind of a settlement that will happen. And we definitely fuel, other than the diesel, CNG, hydrogen, and LNG will be in place for high-powered trucks that we can power, which are less carbon intensive. And very definitely the smaller trucks up to 2 tons will be into EV, and also buses definitely will move to EVs, because buses are going inside a city and charging is much easier into that. So this is just a prediction to say that buses, light commercial vehicles are all going from the present percentage, you can see going up to 60% EV adoption. But when it comes to heavy, medium and heavy duty, you can see the adoption may not go more than 20 to 25% even at 2040. So there will be a combination of alternate fuels. Diesel will be there, there will be CNG, some gaseous fuels, there will be EV. So what will happen is the world will not settle to one or two fuels, but a combination of things which will be better in terms of economics, better in terms of availability. This is what is the world that's going to settle. So we are now looking at something called a closing of a carbon age. Is it true? Probably yes. So we have to look at what is hydrogen. Just to give a good idea of the problem with hydrogen, you can see the density of hydrogen is 0.089 kg per meter cube compared to 830 of diesel. That means to say, to compress, you need to compress hydrogen to a large pressure levels. You want to pack similar quantity of energy, because it's 10,000 times lesser this one. That's why we are talking about hydrogen storage at 350 bar and 700 bar. Diffusivity is very high. That means if it leaks immediately, it gets into the air. Quenching distance is another point. Embrittlement is a problem. It can get into the metals and create brittleness. That's such other challenge. But it needs a very small ignition energy to ignite. That's the risk part of it in terms of safety, but in terms of combustion, it's very good. Auto ignition temperature is higher. As you say, carbon is almost zero. A stoichiometric ratio, that means it needs about 34.5 kg per hour to burn 1 kg of hydrogen compared to diesel, which is 14.5. That means you need lot more air to burn this fuel. So just to summarize, the tailpipe emission of a H2 ICE engine will be almost zero in terms of, except for a small amount of oil that is burning to the piston ring. Renewable energy, as you see, 3 times the energy. Hydrogen has a calorific value about 120 megajoules compared to 42 megajoules of diesel. It's all the carryover parts from diesel can happen. So that means all our supplier base need not have to worry about that the EV is coming and he will not have business. So that answer to it can easily integrate it into our fleet. That means to say service station, mechanics, everything can simply start handling the same thing. TCO will be better, but presently as the diesel hydrogen price drops from below $3 per kg, the hydrogen vehicles will be more better than the diesel vehicles. Lower upfront cost, when I said that, compared to an EV and a fuel cell, H2ICE would be the most competitive in terms of technology for a zero CO2 technology. Reliance on import would come down because India is covered by sea on all the sides. You could use the water to really split water and make it. Resale value of these vehicles, as you see in the EV vehicles, there's a lot of anxiety on the resale value because the battery life is a point. But as you know, in an IC engine vehicle, the resale value will be good. So this is where we do. So we as a Ashok Leyland, you can see that it's not that we are not working on that, but we are working from way back in 1990 for 𝗿𝗄𝗏 with the CNG vehicles. But you know, the availability of CNG across the country was not so great. So it was only predominantly working in cities like Delhi and few in Bombay. But now the adoption is going good. But as a company, you know, we moved from a dual fuel to CNG to LPG to hybrid to ethanol to 85%. We also mixed hydrogen in CNG, which is called HCNG. We are ready with B20, ED7, and going future by another 2025, between 2025 to 2030, we'll be ready with fuel cell electrical vehicle and hydrogen. So that is where the journey that we, not only as Ashok Leyland, I think every OEM are working to make sure that there's an alternate fuels to power their vehicles in the coming year. And this is just to say, we are producing engines from 1.5 liter to 8 liter. As you see the blue line, which is all diesel, but you can see now automatically we are working on CNG, and we are also even working on diesel mixed with methanol and also hydrogen vehicles and already 2 platforms. So this is just to illustrate that if it's a fossil-based fuel, the options are from a diesel to CNG, it's only the change in the tank to a cylinder. And from a hydrogen vehicle, there are options, as I say, H2ICE, where you see that it's only a IC engine which is powered by hydrogen, or it's a fuel cell which then gets into motor and batteries and the wheel that is powering that. These are the only changes that we have to do on a base CNG engines to make it to H2ICE. And these are the components that are required, which is already well developed. There are certain challenges with respect to embrittlement and performance related, but more or less we are working on these areas. This is just to give an idea that we as a company, and I think every company will try to do, addressing something called a flex fuel availability. That means you need to have an engine which is able to work on, or at a vehicle level, we can say the vehicle should be able to adopt to different fuels. You can see here, just by changing the engine and certain tank, this same vehicle, by part number, we will be able to produce a CNG. Similarly, with small changes in the cylinder, it becomes an LNG. Similarly, it becomes an H2ICE. That means you can, our manufacturer can start producing this by just changing the cylinders and the pipings. And you can see here, just by changing the parts which is in the center, a CNG engine would become an engine which is a diesel engine. With this change in the parts would become a CNG, LNG, and hydrogen vehicle. And this is the specification. We've already made a 210 horsepower engine, which was displayed in Auto Expo in 2023. And this has been our journey. From 21, we are working on this very heavily. And probably in the next few years, the maturity will come up. And we as a company, and I think all the companies in the world are looking at how to make the engines to work on hydrogen as a fuel. While we were doing this, you know, we had to handle this fuel. So we learned how to handle this fuel. In our own R&D lab, we did a lot of risk assessment. We did a safety analysis. We did our own gas storage. We had the first PESO approval. We did a gas distribution system of carrying the hydrogen from a yard to the engine. And also we did a lot of, this is our yard. As you can see, we have an approval to carry about 288 cylinders, 316 kgs of gas. So we made this on our own. We also made our test bed system to operate safely. And also you can see if in case of any of this violation, automatically the fuel is cutting off so that it's safe for the operator to work. So these are some of the clear learning, but I would not like you to spend time on the technical part. But you can see the CO2, which was about 30,000 ppm to 1 lakh ppm in diesel, is just 130 to 210. You can see that's the level of CO2 that you're talking about, the tailpipe level. NOx is also more or less controlled. And brake thermal efficiency, you can see it's more or less equivalent to the diesel engines. So in-house development, as you can see that this is a typical way. When I made the first truck myself, you can see it is just running with the steam and water. Okay, that's the typical nature of hydrogen, because it's H2 plus O2, which is H2O. So this is we have already have 10,000 hours of running experience. We have test beds to run it. And definitely we can say we as a company have taken a H2 journey. And this was the first vehicle that we displayed in, as I said, in Auto Expo. And it's also inaugurated as a partner. We work with Reliance, and there are about 23 vehicles running in Jamnagar. This is just a video, but I think it's maybe...
Green mobility. The world now gets a new set of wheels to steer that journey towards reality. Presenting Ashok Leyland's pioneering technology, the hydrogen internal combustion engine vehicle that's built on the 𝗷𝗏𝗃 modular platform. The fuel delivery system on this vehicle is modified to use green hydrogen instead of diesel. A strong carbon fiber composite cylinder ensures safe storage and high pressure endurance of up to 350 bar. That's extremely easy to install, lightweight and maintenance-free. With minor changes to our H series 6-cylinder internal combustion engine, we are able to deliver power and torque equivalent to a conventional engine. With a lean combustion strategy, it ensures minimal emissions and less noise, resulting in an efficient, cleaner and a quiet drive. The hydrogen internal combustion engine vehicle delivers the highest payload and long range. Its aggregates are similar to a diesel vehicle, aiding easier maintenance, all while complementing the hydrogen mission that supports the 𝗍𝗲𝗏𝗃 initiative. These benefits make hydrogen internal combustion engine vehicles a perfect vehicle to drive us towards the future. Ashok Leyland, कोई मंजिल दूर नहीं.
Just to tell you, while we are working on this, as you see that we are already ready with all other alternate fuels or the EV products. You can see buses, and we also have in smaller trucks for the LCV. And you can see already there are certain 55-ton battery electrical vehicles are there, and also a small vehicle with for the we have a 12-ton even a CNG vehicles are available. And these are the higher ones for the fuel cell 6x2 haulage. We have an LNG CNG for 6x4 tractor trailer. And you can see those are the buses which are operating in Leh along with the NTPC for the fuel cell buses. And you can see this is the H2 engine the vehicles that we are already as a trials that we are running today. So going future as a company, I think for the greener mobility, everybody have to look at fuel efficiency in what they're making, cost effectiveness, because we cannot bring expensive technologies to this country where it is very sensitive to price. Emission reduction is our target. Innovative features are required, and safety and durability when we are handling alternate fuels. Thank you very much, and thank you very much for giving me this opportunity. Any questions I can take on?
Yeah, I think as mentioned, I think wonderful, to have you on, on the stage, Yogesh-ji. I still can't get over, but mistakenly call you Dr. Bolar. I don't know why. But many thanks for this, and I think I would like to use this time to ask the audience if they would like to have any questions addressed, to the stage.
Yes, please. Any questions, please? Maybe it's not the topic.
No, it's very much their topic, but maybe it's quite clear, I think. I don't know. Reliance, Tata Motors, I'm just trying to prod. So I think, Yogesh-ji, maybe they'll connect with you over lunch, possibly? Yeah?
Yes.
Yeah, there's one question.
Yeah, good morning. Wonderful presentation, actually. I'm Kishore from Reliance.
Yes.
We are definitely working with you on these hydrogen vehicles, which we are...
Kishore-ji, sorry if I may interrupt you. Mr. Kishore heads the Jamnagar complex, the SEZ complex.
Okay.
Yeah.
Please.
Right. So, while there are a few challenges, of course, definitely that are there in this hydrogen. One is to bring it down to, like you said, less than $3 per kg. That's a big challenge which the world is really facing. To make this entire, the whole chain, in fact, not just production, but distribution, everything, all till the last, till the time it reaches the vehicle. So there is a lot of cost that is involved in getting the hydrogen to the vehicle. So definitely those trucks are running very fine in Jamnagar, and we continue to have our own hydrogen pump there also. The another issue that we need to look for is the safety part of this, right? Though we are also having this carbon fiber related cylinders. Yeah, we are looking, but still the technology, I think, is still
yet to mature.
Yeah, yet to mature. So where do you see that, the safety part? How do you see the safety part being taken care when we have it en masse in the in commercial production and things like that?
Just a anecdote. When I first tested this my engine, my boss is calling me from Chennai. Okay, it was an 𝗍𝗲𝗃𝗍 day. I don't know what came to me. He called me and said, "Yogesh, I want you to fire the hydrogen engine today." He said. So I said, "I don't know what to do." No, कुछ तो करो. एक cylinder, hydrogen cylinder ले लो तो शुरू करो. So I remember I just took a 50-liter bottle. It was CNG engines. So I had no clue. Just I read what are the properties of hydrogen, and for the first crank, the engine just went off. Okay. So just to tell you, yes, there's a lot of challenges when you looked at. I actually covered few part of that, but I've read all the properties of diesel. There are certain things very difficult to handle. But just to give a flip side, when I was in IOCL Faridabad, we were talking to a director. He was telling when IOCL introduced LPG, I believe, the so-called the red cylinders, he said people were not daring to touch that cylinder, thinking that it will explode. But he says, he told me very other way, now you guys see that people, 𝗿𝗲𝗰𝗃 वाला भी उसके ऊपर ही बैठ के 𝗿𝗲𝗃 बनाता रहता है. So that fear itself is gone. So the point is, any hydrocarbon fuels per se, if you don't handle it safely, it is a problem. It could be even for diesel, kerosene, any of this. So hydrogen will also be the similar thing. So we need to follow certain safety protocols. So when you were designing this whole vehicle in terms of sensors, in terms of piping, in terms of joints, in terms of leakage protection, as I showed in our whole beds itself, we have certain things. At a vehicle level, only one concern when I see is if, when the accidents happen, what would happen? So there is, if the vehicle is going to rub against a road, then will the cylinder explode? So whatever I've seen in the Type 4 cylinder, they're making it sure that it collapses but not burst. That's the way the people are looking at it. But yes, there will be certain sensors with which you can immediately switch off the regulator system and not supply the hydrogen. So definitely we'll have to work on safety system, which is even true for CNG and LNG which are running. Even EV, when it goes in the market, you saw for the few times the flame happened and there was a lot of talk about it, but there's a lot of controls which will come. So safety has to come in place. I agree to you.
Thanks.